Hi students, today we're going to be looking at Unit 11, calculation of specific dosage forms, and we are going to be looking at charts. Now we had started metrology and completed the metrology unit, and it dealt with weighing and measuring small quantities, and you're going to use those principles to apply in this particular area. So these are the objectives for the lecture. And just to summarize what the objective is saying, we are going to be looking at the different sources of active ingredients that we may encounter while we are calculating ingredients for preparing charts or divided powder. And we're also going to be looking at how we apply the methods of weighing small quantities in this particular area. So we want to look at some definitions. We want to look at what's a powder. Powder is a solid material that is usually in a finely divided state, and the powder can be used orally as well as externally. You have simple powders that contains only one ingredient, and you have a compound powder that contains more than one ingredient, usually an active ingredient and other excipients such as diluent, sweeteners, and dispersing agents, as well as a compound powder can have one or more active ingredients. Bulk powders are undivided powders. They are useful for non-potent bulky drugs that are used in large doses, and they tend to be a little bit more stable than liquid form because most likely liquid forms have water contained in it. But the focus of our lecture today is divided powders, usually known as charts, are usually referred to as individually wrapped dosage forms. It's useful in that you're going to supply very potent drugs with highest degree of accuracy so that the patient is able to take it without weighing or measuring their own doses themselves. When prepared extemporaneously, doses are wrapped in separate papers. We normally calculate excess because if you should be somebody who cooks in the kitchen often and say you're making Johnny cakes, aka dumplings with flour, you realize that if you're going to make 10 dumplings, you're going to have to use more than what is required to make 10 dumplings in terms of the flour. So you have to make excess to account for loss. We have divided powders on the market. Oral rehydration salts is a very popular one. And we also have Andrews salts used for upset stomach. And if you are not familiar with Andrews salts, this is an example of a divided powder. Now you have 12 sachets, and each sachet will have a dose of the antacid. So we're going to be looking at calculating ingredients for divided powders or charts using pure powder as a source of active ingredient when we have a least weighable quantity that is to be applied. Question says that we're to calculate the ingredients necessary for preparing the prescription below using the stock of hydrochlorothiazide pure powder. It shouldn't be charmterine, I'm sorry for that. The least weighable quantity applied for this question is 120 milligrams. And if you remember what least weighable quantity means, it is the least amount of load or least amount of powder that a scale can weigh with accuracy. Accuracy meaning 5% error. First thing we have to do is interpret what the prescription is saying. The ingredient that we are going to be focusing on is hydrochlorothiazide, which is here on the prescription, 20 milligrams. And the prescription also lists that you are to mix and make charts and send 10 doses. DTD means send such doses. So Dr. Huxtable wants you to send 10 charts, each containing 20 milligrams. Okay? Now, what are the actions that are required for us to accurately calculate all the ingredients necessary to fulfill this prescription? They're all listed here. I'm not going to read them out because we're going to look at all of these actions as we go down. First, we're going to determine what the least weighable quantity is. If you recall from metrology, we can work out the least weighable quantity by using parameters such as the sensitivity requirement and the error that is acceptable. The question did not mention anything about sensitivity requirement or the error, but it mentioned what the least weighable amount is, which is 120. We are also to determine the total charge requested by the prescription. DTD number 10 indicates that the doctor requires 10 charts to be dispensed. Now, because what we are working with are powders, we don't want to make the exact amount of powder for 10 charts, because as you can imagine, if you are weighing, some might be spilled somewhere, you're moving from one area to the next to transfer powders from one container to the next, you're going to have some of that powder being lost. So we have to compound in excess. The general rule of thumb is that we calculate 40% excess of total charts requested by the prescription, and 40% of 10 is 4 charts, and therefore we're going to be calculating for 14 charts. Next, we are going to determine how many milligrams of the active ingredient will be contained in one chart. Here on the prescription, that one chart will contain 20 milligrams. So we're letting hydrochlorothiazide 20 milligrams be contained in each chart. Next, we're going to determine the total active ingredients for total charts to be made. Now, if we know that 20 milligrams of hydrochlorothiazide is in one chart, we can now determine how many will be for 14 charts that we have to compound for. Remember, we are making excess of 10. The excess is 4 because of 40% excess that we're calculating. So we're extemporaneously compounding for 14 charts. And that value is 280 milligrams of the pure hydrochlorothiazide powder. We have to then determine if we need 280 milligrams of hydrochlorothiazide powder to prepare 14 charts. Is that weighable? Yes, it is, because the least weighable quantity is 120. The next step is to determine the source of the active ingredient. Question said it is a pure powder, so that means we are using the pure powder. So all we have to do is go ahead and weigh 280 milligrams of hydrochlorothiazide, which will be now used to make our 14 charts. But we are not making 14 charts all at once. We are making 14 charts. We're individually wrapping 14 charts. So it means then that even though 280 milligrams, which is weighable, is for 14 charts, we can only wrap one chart at a time. So we need to determine the total amount of powder for each chart. And that works out to be 20 milligrams. This is not weighable. Therefore, it means that we are going to have to bulk up this 280 milligrams such that when we weigh or wrap each individual chart, it is weighable. And as it is now, if we divide through 280 milligrams by 14, we will not get a weighable amount. 20 milligrams is way less than 120. So we're going to have to bulk it up. What do we need to bulk it up? We need a diluent. And a diluent is that excipient that has no therapeutic action, but is there to allow our dosage form to be handled. And in this case, allow our dosage form to be weighable so that they can be packaged in individual charts. Next, we are going to choose the weight of each chart, because previously, when we divided 280 milligrams, which is needed for the 14 charts, by 14, we got 20 milligrams. That's not weighable. So we are going to let each chart be weighable. The rule of thumb is we're going to let one chart weigh greater than or equal to the least weighable quantity, which is 120. That means you can let each chart weigh 120, 130, 150, 160, 200, and so on. But we should be very careful in that if you should be pricing this prescription for a patient, each milligram of your powder has a cost. So if you're going to use too much, it means it's going to cost the person more. And if the person is going around to try to get quotation on prices, it simply means that they may not come back to your pharmacy if you're not very conservative in the amount of diluent you're using. But this calculation, we're going to stick with the least weighable quantity. So we're letting each chart weigh 120, and 14 charts, therefore, will weigh 1,680 milligrams. This means the total mixture for the 14 charts will be 1,680 milligrams. If the total mixture of our chart for the total mixture or powder mixture for a 14 chart is 1,680, we need to determine how did we get that. We added a diluent. How much of the diluent did we need to add? We therefore subtract the 280 milligrams of the hydrochlorothiazide from the 1,680 total mixture to get the diluent. So our new formula for making our 14 charts is hydrochlorothiazide 280 milligrams, and the diluent, which could either be starch or lactose, is 1,400 milligrams. This means that we're going to mix these two powders using geometric dilution and weigh 10 portions of 120 milligrams. Each now will contain the 20 milligrams of hydrochlorothiazide that you will require. And the instructions that you would put on the label would be enter the contents of one chart in 30 ml of water or juice and drink. And this is to be done once daily as per the signature of your prescription. You can always double check to see if every 120 milligrams of this powder mixture will contain the 20 milligrams of hydrochlorothiazide. All you have to do is to say if 280 milligrams of hydrochlorothiazide is contained in 1,680 milligrams of powdered mixture, therefore X milligrams of hydrochlorothiazide will be in 120 milligrams. And then you can confirm whether or not the 120 milligram portions will each contain 20 milligrams of the hydrochlorothiazide, which is what is the dose on the prescription. I hope that you would have understood the first problem in terms of charts and divided powders. This is a very simple calculation, and we are going to go to another type of problem that you will encounter in your calculations. But before we do, I want to allow you to watch a video on divided powders. And then after that, we will take up the other question.